Okay, what we're going to do is walk through this little problem where it says a certain company's monthly profits, P of t, are growing at the rate of R of t equals 1 over t thousandths per month. Little bit by little bit, it says find and interpret R of 10. Well, the first thing you're going to see there that if R of t is 1 over t thousandths per month, then R of t is the derivative of P of t. So you can see when we started doing this problem, that's the first thing I wrote down. They called it R of t for rate, but it really is the derivative of p. So I'm going to write it that way. And you can see that I wrote p prime of 10, which is what it is equal to R of 10. And I just plugged in 10. And so I'm going to get 1 over 10. Remember, that's thousandths per month. Well, that doesn't make any sense. How about $100 per month? That's fine. Remember, that's a derivative. What did that mean? That should mean, for example, that in the 11th month, our profit is $100 more, roughly, than it was in the previous month. That's all that means. Now let's go back and look at the second part of the question. Second part of the question says, if we take as known that the derivative of ln of t equals 1 over t, we could certainly confirm that graphically, so it's not so bad. Find the exact value of the integral from 10 to 20 of 1 over t dt. We'll do that first, and then we'll try to interpret it, I think. So what do we want? We want to use the fundamental theorem of calculus. Let's see here. I guess I'm going to have to write this as I go along. Now the fundamental theorem of calculus, I'll write it right below like this, says if we're looking at an integral, let's say from a to b, and let's call this p prime because that's what it is, like that, right? It says that that's equal to p of b minus p of a. In other words, if someone gives us an integral and we can recognize this function right in here, that function is called the integrand, but we won't have to use those words for a long time, as the derivative of something specific, we can use the something specific to evaluate the integral exactly. For example, they told us that the derivative of the ln of t equals 1 over t, like that. And what does that tell us? That tells us that this is p prime, and then we can use this as p. And so what we want to do is plug in 20, plug in 10, and subtract. The way they usually write this, I'm going to write down ln of t, and remember, that's an evaluation bar. That just says plug in 10, but because they're plugging in two different things, they actually do something called abusing the notation, and they put a 20 up here. Now, they've been doing this for 200 years, so people aren't surprised that they do it, but the evaluation bar came first. And so what we're going to get here is going to be, let's see here, the ln of 20 minus the ln of 10. We don't have to do this, but I'm going to anyways. I'm going to write down that this is the ln of 20 over 10, which is just the ln of 2. I'm going to walk over to my calculator. I'm not lying. See, here's my calculator. And I'm going to put in the ln of 2, and I get 0.693. We'll just leave it at that for the moment. Equals 0.693. Now this is going to be in thousands, so I'll put one more like that. This is thousands. So this is the exact value, this is the estimate. What does this mean if I try to interpret this? Well, I'm going to talk my way through it and I'll let you write it out. I will say, if you're a non-math major, this is the most important step, so let's just think about that for a second. What is this, right? It's thousands. Now, what went up? The monthly profit. So that says from the 10th month to the 20th month, the monthly profit went up about $693. In other words, the 20th month was much more profitable. How much more profitable? About $693. I'll let you do part C.